Okay, in this video, we're going to solve this problem right here, and so let's begin. So x squared times x squared is x raised to 4 times x is x raised to 5. Now, because the denominator power is 5 and the numerator power is 4, we're going to need to use partial fractions. And so let's begin. So what I'm going to do first is ignore the integral and create my partial fraction. So I have x raised to 4 plus 5 divided by x parentheses x squared plus 1, close it, raise it to 2, is equal to. Now this type of problem, I classify it as type 4 repeated quadratic factor because we have an x squared plus 1 and we're squaring it. And so we're going to get a divided by x, this piece right here, plus bx plus c divided by x squared plus 1 because we have x squared plus 1 plus dx plus e divided by parentheses x squared plus 1, close it, squared. Now to avoid fractions, I'm going to multiply everything by x times parentheses x squared plus 1, close it, squared. This will cancel this denominator and we're going to get x raised to 4 plus 5 is equal to a parentheses x squared plus 1, close it, squared, because the x's cancel, plus parentheses bx plus c, close it, times x squared plus 1, close it. Because this piece is missing this x, and it's also missing another x squared plus 1, plus parentheses dx plus e times our x. So next we're going to expand, so we have a parentheses x raised to 4 plus 2x squared plus 1. Because x squared times x squared is x raised to 4, 1 times 1 is 1, x squared times 1 is 1x squared, likewise 1 times x squared is also 1x squared, so we get 2x squared. Now we'll do this piece, so plus parentheses bx plus c, close it, parentheses x times x squared is x cubed, x times 1 is x, plus this one we can expand, dx squared plus ex. So now let's distribute the a. So we're going to get ax4 plus 2ax squared plus a. Then we'll do this piece. Plus bx raised to 4 plus bx squared plus cx cubed plus cx. Then we copy what we have. dx squared plus ex. Now we're going to write our system of equation, but we're going to need more room, but we can at least write the systems of equation. So we have x raised to 4, we have it here also, and here. So we can say that 1x raised to 4 is equal to a plus b. Now we don't have an x cubed, so I'm going to say 0 is equal to, we have an x cubed here, so 0 is equal to c. Now we don't have an x squared either, so we're going to say that 0 is equal to, we have an x squared here, we have an x squared here, and we have an x squared here. So 0 is equal to 2a plus b plus d. Now we also don't have an x here, so we can say that 0 is equal to, we see, where do we have an x? We have an x right here and here. So 0 is equal to c plus e. Lastly, our constant, so 5, we have an a, and that's all we have. So 5 is equal to a. So let's solve these letters. So we know a is equal to 5. We know c is equal to 0. Now if a is 5, we have 1 is equal to 5 plus b, then b has to equal negative 4. So we know b is negative 4. And we know this because 5 minus 4 is 1. Likewise, if c is 0, e is also 0 because it says 0 is equal to 0 plus 0. So e is also 0. So we know e is also 0. Now just d. So a is 5, so 10, plus b is negative 4. 10 minus 4 is 6. 6 plus something gives you 0. So d must be negative 6. So d is equal to negative 6. At this point, we're going to rewrite. We know a is 5, and put 5 divided by x. We know b is negative 4, so negative 4x plus c is 0. So negative 4x divided by this piece. And we know d is negative 6, so negative 6x plus e, which is 0. So negative 6x divided by this piece. And so we're going to do this in the next slide. And so let's swap. So we have the integral. Instead of saying a divided by x, we're saying 5 divided by x dx plus the integral. We know b b is negative 4, so negative 4x, and c is 0, so divided by x squared plus 1 dx, plus the integral d is negative 6, so negative 6x, and e is 0, so negative 6x divided by parentheses x squared plus 1, close it, squared dx. So now this is a pretty easy problem. This piece right here, we're going to have to use u substitution, so I can say that u is equal to x squared plus 1, so then du is equal to 2x dx, therefore du divided by 2 is equal to x dx. Same idea for this piece, we can say that g is equal to x squared plus 1, so dg is equal to 2x dx. Then we can say that dg divided by 2 is equal to x dx. And so now let's solve. This piece is very easy. It's just going to be 5 ln, the absolute value of x. Then we have this piece. So x dx, I'm going to replace it with du divided by 2. So we can say that we have plus the integral. The negative 4 I'm going to put in the front. Now this piece we're going to apply our u substitution. So the negative 4 I'll bring it to the front also. So negative 4 the integral. X dx I'm replacing it with du divided by 2. So I'm just going to put 1 divided by u because u is x squared plus 1. So 1 divided by u times du divided by 2. Same idea for this piece. I'm going to bring the negative 6 to the front. So negative 6 the integral. X dx, I'm replacing it with dg divided by 2. And so we can say that we have 1 divided by x squared plus 1, we know is u, so u squared times dg divided by 2. And then we have x dx, and x dx is the same as dg divided by 2. And so we're going to get 1 divided by x squared plus 1, we know is g. So we have g squared times dg divided by 2. We're going to need a little bit more space, so I'm going to take this to another page. And so we have 5 ln, the absolute value of x. Negative 4 divided by 2 is negative 2. And the integral of 1 over u is going to give us ln, the absolute value of u. And u is x squared plus 1. So we can just swap x squared plus 1, close it. Then we have negative 6 divided by 2, which is negative 3, the integral. Instead of saying 1 over g squared, I'm going to say g raised to negative 2 dg. So one more step. So we're almost there. So all of this I'm going to keep the same. So 5 ln, absolute value of x, close it, minus 2 ln. Now let's look at here. X squared plus 1. It says absolute value. So if x is negative 5, you get negative 5 times negative 5, 25. 25 plus 1 is 26. So no matter what, this piece right here will always be positive. So there's no need for an absolute value symbol. So I'm going to use a regular parentheses, x squared plus 1, close the regular parentheses. Then we'll do this piece. So negative 3 times g raised to negative 1 divided by negative 1 plus c. And our last step is to swap. So we have 5 ln absolute value of x minus 2 ln parentheses x squared plus 1, close it. Negative 3 divided by negative 1 is positive 3, and it's g raised to negative 1, so we can put g in the denominator, and we know g is x squared plus 1. So 3 divided by x squared plus 1 plus c, and this right here is our final answer. And that's all we need to do for this problem.